Hello, Namaskara ಎಲ್ಲರಿಗೂ. I welcome you all to the ನಮ್ಮ ವೇದಾಂತ SSLC. ನಾನು ನಿಮ್ಮ ಮಾಸ್ಟರ್ ಟೀಚರ್ Rithika Ma'am. So ಇವತ್ತಿನ ಚಾಪ್ಟರ್ ಯಾವ್ದಪ್ಪ? ಮ್ಯಾಗ್ನೆಟಿಕ್ ಎಫೆಕ್ಟ್ಸ್ ಅಂಡ್ ಎಲೆಕ್ಟ್ರಿಕಲ್ ಕರೆಂಟ್. ಸೊ ಇದು ಫಿಸಿಕ್ಸ್ ಚಾಪ್ಟರ್, ಹ್ಯಾಸ್ ಯು ಪೀಪಲ್ ನೋ ಇಟ್ ಆಲ್ರೆಡಿ. ಸೊ ಇವತ್ತು ಈ ಚಾಪ್ಟರ್ ನಲ್ಲಿ ಸ್ವಲ್ಪ ನ್ಯೂಮರಿಕಲ್ ಪ್ರಾಬ್ಲಮ್ಸ್ ಅನ್ನು ಇರುತ್ತೆ, ಆಯ್ತಾ? ಸೊ ಇಫ್ ಇನ್ ಕೇಸ್ ಯು ಪೀಪಲ್ ಆರ್ all new to the channel, make sure to subscribe to the channel first so that you will have every idea that ಏನೇನು ನಾವು ನಮ್ಮ ವೇದಾಂತ SSLC ಅಲ್ಲಿ ಹಾಕ್ತಿದ್ದೇವಲ್ಲ ಎಲ್ಲ ನಿಮಗೂ ಐಡಿಯಾ ಗೊತ್ತಾಗುತ್ತೆ, ತಿಳಿತಾ? ಸೊ ಆ್ಯಂಡ್ ಥ್ಯಾಂಕ್ ಯು ಸೋ ಮಚ್ ಫಾರ್ ಗಿವಿಂಗ್ ದ ಲವ್ ಫಾರ್ ಮೈ ಪ್ರೀವಿಯಸ್ ವಿಡಿಯೋಸ್ ಆಲ್ಸೋ. ಎಲ್ಲರೂ ಚೆನ್ನಾಗಿ ಲೈಕ್ ಮಾಡ್ತಿದ್ದಾರೆ, ಬಟ್ likes bala kadame ide. So make sure you people will mark your attendance also, whoever it is seeing the classes, so that it is helpful to us also to understand, and we need your feedback. If any changes is necessary, you can tell it in our comment section also. If you are very new to the channel, ಯಾರು ರಿತಿಕಾ ಮ್ಯಾಮ್ ಗೊತ್ತಿಲ್ಲ ಅಂದರೆ ಹೋಗಿ ರಿತಿಕಾ ಮ್ಯಾಮ್ ಯಾರಂತ ಗೊತ್ತಾಗುತ್ತೆ ನಮ್ಮ ವೇದಾಂತ SSLC ನಲ್ಲಿ, ಹೋಗಿ ಸಬ್ಸ್ಕ್ರೈಬ್ ಮಾಡಿ, ಆಯ್ತಾ? ಸೊ ಲೆಟ್ಸ್ ಸ್ಟಾರ್ಟ್ ದ ಚಾಪ್ಟರ್ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಎಫೆಕ್ಟ್ಸ್ ಆಫ್ ಎಲೆಕ್ಟ್ರಿಕಲ್ ಕರೆಂಟ್. ಸೊ ಈ ಚಾಪ್ಟರ್ ಇಂದ ಎಷ್ಟಪ್ಪ ಮಾರ್ಕ್ಸ್ ಬೀಳ್ಬೋದು? ಫಿಸಿಕ್ಸ್ ಚಾಪ್ಟರ್ ಅಂತ ಗೊತ್ತಾಯ್ತು ಎಲ್ಲರಿಗೂ, ರೈಟ್? ಫಿಸಿಕ್ಸ್ ಚಾಪ್ಟರ್ ಅಂತ ಎಲ್ಲರಿಗೂ ಗೊತ್ತಾಯ್ತು. ಈಗ ಎಷ್ಟು ಮಾರ್ಕ್ಸ್ ಬೀಳುತ್ತೆ ಅನ್ನೋದು ಗೊತ್ತಾಗ್ಲಿಲ್ಲ. ಸೊ ಯು ಪೀಪಲ್ ಮೈಟ್ ಗೆಟ್ 8 to 9 marks from this chapter. Okay, you might get how much? 8 to 9 marks from this chapter. Clear everyone? Magnetic effects of electric current ಇಂದ almost 8 to 9 marks ಆರಾಮಾಗಿ ನಿಮಗೆ ಸ್ಕೋರ್ ಮಾಡ್ಬೋದು. ಬಟ್ ಮೇನ್ ಥಿಂಗ್ ಅಂದರೆ, ನನಗೆ ಭಾಳ ಮಂದಿ ಮೋಸ್ಟ್ ಇಂಪಾರ್ಟೆಂಟ್ ಕ್ವಶನ್ಸ್ ಕೇಳ್ತಿದ್ರು, ಅದನ್ನು ಸ್ಟಾರ್ಟ್ ಮಾಡ್ತೇವೆ. ಬಟ್ ಮೇನ್ ಥಿಂಗ್ ನಿಮಗೆ ಏನು ಹೇಳಬೇಕಾದ್ರೆ, ಫಸ್ಟ್ ಯು ಪೀಪಲ್ ನೀಡ್ ಟು ಲರ್ನ್ ಥಿಯರಿ. ಥಿಯರಿ ಎದಕ್ಕೆ ಇಂಪಾರ್ಟೆಂಟ್ ಇದೆ ಹೇಳ್ತೇನೆ. ಫಸ್ಟ್ ನಿಮಗೆ ಥಿಯರಿ ನೀವು ಓದಿದ್ರೆ ಆ ಕಾನ್ಸೆಪ್ಟ್ನಲ್ಲಿ ಏನಿದೆ ಮತ್ತು ಹೇಗೆ ಕ್ವಶನ್ ಅಟೆಂಪ್ಟ್ ಮಾಡ್ಬೇಕು ಅನ್ನೋದು ನಿಮಗೆ ಐಡಿಯಾ ಗೊತ್ತಾಗುತ್ತೆ. ಸೊ ಅದ್ರ ಸಲುವಾಗಿ ಹೇಳೋದು, ಥಿಯರಿ ಚೆನ್ನಾಗಿ ಕುಂತು ಓದಿ ಅಂದರೆ ನಮಗೆ ಈಸಿ ಆಗೋದು. ಡನ್ನ? ಲೆಟ್ಸ್ ಸ್ಟಾರ್ಟ್ ನೌ. First, the introduction, that is magnetic field and the field lines. Magnetic field and the field lines means what? So before we go, we have one small story, okay? Magnetic field ಮತ್ತು magnet ಒಂದು small story ಇದೆ. ಐ ಥಿಂಕ್ ನೀವು 8th ಮತ್ತು 9th ನಲ್ಲಿ ಕಲ್ತಿರ್ಬೋದು ಆ ಸ್ಟೋರಿಯನ್ನು, ಬಟ್ ನಿಮಗೊಂದು ಕ್ವಿಕ್ ಆಗಿ ಹೇಳ್ಬಿಡ್ತೇನೆ, ಆಯ್ತಾ? ಸೊ ಒಂದು ಮನುಷ್ಯ ಇದ್ನಂತೆ, ಓಕೆ? ಒಂದು ಮನುಷ್ಯ ಇದ್ದ. ಆ ಮನುಷ್ಯ ನಡ್ಕೊಂತ ಹೋಗ್ತಿದ್ದ ಅಂತೆ, ಓಕೆ? ನಡ್ಕೊಂತ ಹೋಗುತ್ತ ಮುಂದೆ ಏನಾಯ್ತಂದ್ರೆ, ಏನೋ ಒಂದು ಅವಂಗೂ ಕಾಣ್ಬಿಡ್ತಪ್ಪ, ಸ್ಟೋನ್ ಥರ, ಓಕೆ? ಸೊ ಆ ಸ್ಟೋನ್ ಏನಾಯ್ತಂದ್ರೆ ಹೋಗಿ ಎಲ್ಲದಕ್ಕೂ ಅಟ್ಯಾಚ್ ಆಗ್ಲಿಕ್ಕೆ ಸ್ಟಾರ್ಟ್ ಆಯಿತು, ಮೀನ್ಸ್ ಐರನ್ ಐಟಮ್ಸ್ಗೆಲ್ಲ, ತಿಳಿತಾ? ಸೊ ಹಿ ಗಾಟ್ ಟು ನೋ ದಟ್ ಎಸ್, ದಿಸ್ ಇಸ್ ಸಮಥಿಂಗ್ ಮ್ಯಾಜಿಕ್, right? So ಇದೇನೋ ಇನ್ವೆನ್ಷನ್ ಇದೆ. ಸೊ ದೆನ್ ಹಿ ಇನ್ವೆಂಟೆಡ್ ದಟ್ magnet. So now magnet is like used in every other things. ನೀವು ಗೊತ್ತಿರಬೇಕು, ಮ್ಯಾಗ್ನೆಟ್ ಇಲ್ಲದೆ ನಮ್ಮ ಲೈಫೇ ಏನೋ ಆಗಿಬಿಡ್ತಿತ್ತು. ಸೊ ಅದ್ರ ಸಲುವಾಗಿ ಮ್ಯಾಗ್ನೆಟ್ ಪ್ಲೇಸ್ ಅ ವೆರಿ ಇಂಪಾರ್ಟೆಂಟ್ ರೋಲ್. ಮತ್ತು ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಎಫೆಕ್ಟ್ಸು ಅದು ಹೇಗೆ ಎಲೆಕ್ಟ್ರಿಸಿಟಿ ಜೊತೆ ಕನೆಕ್ಟ್ ಆಗುತ್ತೆ ಅವನ್ನೆಲ್ಲ ಈ ಚಾಪ್ಟರ್ನಲ್ಲಿ ನಾವು ಕಲಿತೇವೆ, ಆಯಿತಾ? ಸೊ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಆ್ಯಂಡ್ ದ ಫೀಲ್ಡ್ ಲೈನ್ಸ್. ವಾಟ್ ಈಸ್ ದ ಮೀನಿಂಗ್ ಆಫ್ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್? ಸೊ ಈಗ ಯಾವುದಾದ್ರೂ ಒಂದು ಮ್ಯಾಗ್ನೆಟ್ ಇದೆ, ಲೈಕ್ ಎಕ್ಸಾಂಪಲ್ ನಾನೊಂದು ಮ್ಯಾಗ್ನೆಟ್ ತೊಗೊಂಡಿದ್ದೀನಪ್ಪ, ಓಕೆ? ಸೊ ಈ ಮ್ಯಾಗ್ನೆಟ್ದು ಕೆಪಾಸಿಟಿ ಎಷ್ಟಿದೆ? ದಿಸ್ ಮಚ್ ಈಸ್ ಇಟ್ಸ್ ಕೆಪಾಸಿಟಿ. ಕ್ಲಿಯರ್? ಸೊ ಈಗ ಸೇಮ್ ಅದೇ ಥರ ನಾನು ಒಂದು ಮ್ಯಾಗ್ನೆಟು, ಆರ್ ಎಲ್ಸ್ ಐ ಆಮ್ ಅ ಹ್ಯೂಮನ್ ಬೀಯಿಂಗ್ ಹೂ ಕ್ಯಾನ್ ಈಟ್ 2 ಚಪಾತೀಸ್, ಲಿಟಲ್ ಬಿಟ್ ಆಫ್ ರೈಸ್ ಆ್ಯಂಡ್ ಅ ಬ್ಯಾಲೆನ್ಸ್ಡ್ ಫುಡ್. ನಾನು ಕುಂತೀಗ ಎಷ್ಟು ಕುಂತು ತಿಂತೇನೆ ಅಂದರೆ ಆಗತ್ತಾ? ಆಗಲ್ಲ. ಎದಕ್ಕಪ್ಪ ಆಗಲ್ಲ ನನಗೆ? ಬಿಕಾಸ್ ಮೈ ಕೆಪಾಸಿಟಿ ಇಸ್ ದ್ಯಾಟ್ ಮಚ್, ಮೈ ಲಿಮಿಟ್ ಇಸ್ ದ್ಯಾಟ್ ಮಚ್. ಅದೇ ಥರ ಈ ಮ್ಯಾಗ್ನೆಟ್ದು ಫೀಲ್ಡ್ ಇಸ್ ಓನ್ಲಿ ದಿಸ್ ಮಚ್. ಈ ಫೀಲ್ಡ್ನಲ್ಲಿನೇ ಅದು ಅಟ್ರಾಕ್ಟ್ ಆಗೋದು, ಇದಕ್ಕಿಂತ ಜಾಸ್ತಿ ಹೊರಗೆ ಹೋದರೆ ಅದು ಅಟ್ರಾಕ್ಟ್ ಆಗಲ್ಲ. ಕ್ಲಿಯರಾ? So the space around the magnet in which the force of attraction and the repulsion caused by the magnet can be detected is called as magnetic field. It can be detected is called as magnetic field. Clear? Next, the curved paths along which iron fillings arrange themselves due to the force acting on them in the magnetic field of bar magnet are called as magnetic field lines. So magnetic field lines ಅಂದ್ರೇನು? ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಅಂತ ತಿಳಿತಾ ಎಲ್ಲರಿಗೂ? ಈಗ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಲೈನ್ಸ್ ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್ ಮಾಡ್ಕೊಳ್ಳೋಣ, ಆಯ್ತಾ? ಸೊ ಈಗ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಅಂದರೆ ಒಂದು ಏರಿಯಾ ಹೇಳಿದೆ ನಿಮಗೆ, ಆ ಏರಿಯಾನಲ್ಲಿ ಆ ಎಫೆಕ್ಟ್ ಇದೆ ಅಂತ. ಮ್ಯಾಗ್ನೆಟಿಕ್ ಲೈನ್ಸ್ ಅಂದರೆ ಏನೀಗ? ಲೈನ್ಸ್ ಅಂದರೆ ಇದು ಬಂದು ಬಾರ್ ಮ್ಯಾಗ್ನೆಟ್, ಓಕೆ? ಯು ಪೀಪಲ್ ಹ್ಯಾವ್ ಆಲ್ರೆಡಿ ಲರ್ನ್ಡ್ ದಿಸ್ ಬಾರ್ ಮ್ಯಾಗ್ನೆಟ್, ವಿಚ್ ಆರ್ ಬಾರ್ ಮ್ಯಾಗ್ನೆಟ್, ಹಾರ್ಸ್ ಶೂ ಮ್ಯಾಗ್ನೆಟ್, ಲೋವರ್ ಕ್ಲಾಸಸ್ನಲ್ಲಿ ಕಲ್ತಿರ್ತಾರ, ರೈಟ್? ನಾವು ದಿಸ್ ಬಾರ್ ಮ್ಯಾಗ್ನೆಟ್ ವಿಚ್ ಇಸ್ ಪ್ರೆಸೆಂಟ್, ವಿಚ್ ಇಸ್ ಹ್ಯಾವಿಂಗ್ ಅ ನಾರ್ತ್ and yes pole, means north and south poles adave. So ee north ಮತ್ತೆ south pole ನಲ್ಲಿ ಇಲ್ಲೇನಿದೆ ಅಲ್ಲ, this is all the capacity it has. But here the power is very less. Here at the between, the power is very less. Yakappa power less ade kadame ide naduvu, because alli magnetic lines rich agalla. Alli magnetic lines rich agalla. Adakke enanta karitare, magnetic lines will be very active at the corners of the pole. Okay, at the corners of the pole, not at the middle of the pole. Then understood? Done. Yes. Next one. The direction of the magnetic field at any point is obtained by drawing a tangent that is tangent to the field line at that point. Okay, like the direction of the magnetic field at any point is being obtained by drawing the tangent to the field line at a point. Like, what is the properties of a magnetic field? Okay, this is very important. 2 to 3 marks question keltare properties of magnetic lines mele. Aita? So the properties of magnetic lines is, first point is, the magnetic field line is directed from north pole to the south pole outside the magnet. Okay, this is how the north pole and south pole is been directed. Clear? Next, magnetic field line is closed and continuous curve. Magnetic field line is what? Closed and continuous curve. It is closed and it is continuous. See, so many lines are present, guys. This is what it tells. Next quote, the magnetic field lines never interact each other. They will never interact each other. Clear? Next, the parallel and the equidistant field lines represent a uniform magnetic field. It will represent a uniform magnetic field, which parallel and equidistant field will actually represent a uniform magnetic effect. Uniform magnetic effect. Clear? Next, magnetic field due to the straight current carrying conductor. Magnetic field, how it's going to work with the straight carrying conductor. Therita, ಈಗ ನಿಮಗೆ definition of magnetic field ಗೊತ್ತಾಯ್ತು, magnetic lines ಅಂದ್ರೆ ಏನಂತ ಗೊತ್ತಾಯ್ತು, ಈಗ ಅದರದ್ದು ಪ್ರಾಪರ್ಟೀಸ್ ಅನ್ನು ಗೊತ್ತಾಯ್ತು. ಈಗ ನೆಕ್ಸ್ಟ್ ಏನು ಸ್ಟಡಿ ಮಾಡೋದು, magnetic field ಇಂದ ಏನೇನಪ್ಪ ಆಗುತ್ತೆ. Okay, so first ಯಾವುದು, magnetic field due to the straight current carrying conductor. Straight current carrying conductor. So that is the magnetic field lines around a straight conductor is carrying a current are concentric circles. At the concentric circles. Concentrate properly here. So ಇಲ್ಲಿ ಒಂದು magnetic line ಇದೆ. One second. Okay, so ಇದು magnetic line ಇಷ್ಟು. Okay, ಇದು ಒಂದು, ನೆಕ್ಸ್ಟ್ ಇದು ಒಂದು, ಇಲ್ಲಿಂದ ಇಲ್ಲಾಗ್ತಿದೆ. ಒನ್ ಸೆಕೆಂಡ್. ಕ್ಲಿಯರ್ ಆಗಿ ಕಾಣ್ತಿದೆನಾ ಎಲ್ಲರಿಗೂ? ಇದು ಕೀ, ಇದು ರೆಸಿಸ್ಟೆನ್ಸ್, ಇದು ಎಮೀಟರು, ಇದು ಬ್ಯಾಟ್ರಿ, ನೆಗೆಟಿವ್, ಇದು ಪಾಸಿಟಿವ್. ಸೊ ಇದೇನಿದೆ ಅಲ್ಲ, this is what is there, no? How the current is being passed. Okay, ಇಲ್ಲಿ current ಹೇಗೆ ಪಾಸ್ ಮಾಡ್ತಾರೆ and how it is being in the form of a circle. It is in the form of what? In the form of a circle. Clear? That is what clearly I wanted to tell you people. Magnetic field lines around a straight conductor, carrying a current are concentric circles. This is around a conductor. It is actually acting like a concentric circle. Means circle tara act ಮಾಡುತ್ತೆ. Current ಹೇಗೆ ಪಾಸ್ ಆಗುತ್ತೆ? Concentric circle ತರ ಪಾಸ್ ಆಗುತ್ತೆ. Clear? Next, the direction of the magnetic field, which is present. One second, guys. Yes, the direction of a magnetic field is given by right hand thumb rule. So ಅದೇನ್ direction of a magnetic field ಇದೆಯಲ್ಲ, concentric circle ದು, ಅದರದೊಂದು ಇನ್ನೊಂದು ರೂಲ್ ಇದೆ, right hand thumb rule. So ಈ right hand thumb rule short question exam ನಲ್ಲಿ. Okay, this is short question for exams. Aita, please don't forget this. Okay, the direction of a magnetic field is given by right hand thumb rule. How it works? So this is the thumb rule which is present. I'm not getting anything right now, but idrinda tostane. Okay, this is our thumb. Clear? ಅವನು ಹಂಗೆ ಹಿಡಿದಿದ್ದಲ್ಲ ಈ ತರ, right? ಈ ತರ ಹಿಡಿದಿದ್ದಾನೆ, right? Here only it is. Here, okay? This is a magnetic field. This is how the magnetic field is. ಈ ತರ, okay? This is how the magnetic field is. Then the current is being passing here. The current is this. The current ಇದು current ಆಮೇಲೆ ಇಲ್ಲಿಂದ ತರ ಹಿಂಗ್ ಪಾಸ್ ಆಗ್ತಿದೆ. This is how it is getting passed. Clear? So whatever the current is being getting passed at the thumb, this thumb, okay? Next here same way again. I am taking it opposite way, okay? ಇಲ್ಲಿ opposite way ಹಿಡ್ಕೊಂಡಿದ್ದೇನೆ, ಇಲ್ಲಿ current ಮತ್ತೆ ಪಾಸ್ ಆಗ್ತಿದೆ ಈ ತರ. Clear? How this is how the thumb rule is going to work. This is our right hand. I don't know how in the video how it's been looking. Right hand ತೋರಿಸ್ತಿದ್ದಾರೆ, left hand ತೋರಿಸ್ತಿದೆ ಗೊತ್ತಿಲ್ಲ, but just take it out, okay? So this is how the right hand rule works. This is a magnetic field. ಈ ತರ circle ಆಗಿ form ಆಗುತ್ತೆ. Clear? ಇಲ್ಲಿ ಈ ತರ rotate ಆಗುತ್ತೆ, ಇಲ್ಲಿ ಈ ತರ rotate. Means thumb rule ಇಂದ. Thumb ಎಲ್ಲಿದೆ ಅಲ್ಲ, ಇಲ್ಲಿ thumb ಇದೆ ಅಲ್ಲ, ಇಲ್ಲಿಂದ ಈ ಹಿಂಗಿದ್ರೆ that's it. Done? Next, right hand thumb rule, that is, imagine that you are holding a straight current carrying conductor in your right hand such that the thumb points towards the direction of the current. Then your curved fingers wrapped around the conductor point in the direction of the field lines in the magnetic field. Just now I explained the same way it has been affected here. Clear? Next, the magnitude of the magnetic field due to the straight current carrying conductor at a given point is. How the magnitude of the magnetic field is. Magnitude on the direction. Yav tara direction ide magnetic field idu. Okay, let's say directly proportional to the current flow. It's actually it is directly proportional to the current flowing through the conductor. It's directly proportional to the current which is flowing through the conductor. Next, it is inversely proportional to the distance to that point from the conductor. Inversely proportional to the distance of that point from the conductor. Clear? Inversely proportional ide, idu directly proportional ide. Then this is also very important, 2 marks question idono aita. Idu 2 marks question na. Next, magnetic field due to the current carrying circular coil. Magnetic field due to the current carrying circular coil. ಹೇಗೆ current carrying circular coil ಆಗುತ್ತಪ್ಪ, ಇಲ್ಲಿ ನೋಡಿ ಚೆನ್ನಾಗಿ ನೋಡ್ಕೊಳ್ಳಿ ಇಲ್ಲಿ ಹೇಗೆ ಆಗ್ತಿದೆ ಅನ್ನೋದು. ಓಕೆ, ಸೊ ಇದು ನಾರ್ತ್ ಪೋಲು, ಇದು ಸೌತ್ ಪೋಲು. This is north pole, this is south pole. Clear? So the how the effects are happening. ನಾ ಹೇಳಿದೆ ಮಿಡ್ಲ್ ಅಷ್ಟಿರಲ್ಲ ಅಂತೆ, ಸೇಮ್ ಅದೇ ಆಗೋದಿಲ್ಲಿ ಆಯ್ತಾ. This is how the current means it is in a curved shape. ಮೇಲ್ಗಡೆನೂ ಕರ್ವ್ಡ್ ಇರುತ್ತೆ, ತೆಳಗಡೆನೂ ಕರ್ವ್ಡ್ ಇರುತ್ತೆ ಆಯ್ತಾ. So the magnetic field lines, is it visible properly? Yes. The magnetic field lines near the coil are nearly circular and concentric. It's actually nearer to the circular and concentric. Circular and concentric. ಇದಕ್ಕೆ circular and concentric, these things which we are discussing. Okay, this is circular, nearer and circular. Okay, these are what? Circular or concentric. Circular or concentric. Next, the magnetic field at the center of the coil is maximum and almost uniform. Okay, it's actually maximum and it's almost uniform. Uniform ಅಂದ್ರೆ ಏನು? Correct shape ನಲ್ಲಿನ magnetic lines form ಆಗುತ್ತೆ. You can just observe. The shape is same. It's not like any diversion is happening in between. It's completely uniform. Clear? ಆಮೇಲೆ ಏನಾಗುತ್ತಪ್ಪ, looking at the face of the coil, if the current amount around it is being clockwise direction, then it faces the south pole. Then it will start facing what? South pole. It will start facing south pole. Now, if the current around it is in the anti-clockwise, if it is in the form of a anti-clockwise is the opposite to the clockwise. Okay, so adake enagutte direction, then one second, then it faces from the north pole. So that is actually called as what? Clock rule. That is called as what? clock rule. Clock rule also has been asked 2 marks ko. So make sure you people will practice that. Okay. Next, the magnitude of the magnetic field at the center of the coil is. What is the magnitude of the magnetic field at the center of coil? At the center of coil, what is the magnitude of that magnetic field? Clear? First point is what? It's directly proportional to the current flowing through it. It's directly proportional. Whatever the current is being flowing through it, it's directly proportional to that. Clear? Next, inversely proportional to the radius of the coil. It's inversely. This directly proportional to the current of the flowing current. Directly proportional to flowing current. Means you can write it in this way also. Okay. Magnitude is directly proportional to current. Clear? Current C nu use madbodu. Usually use current Q also. Okay. Inversely proportional to the radius of the coil. M is inversely proportional to the radius of the curve. Clear? Radius of the curve. It's visible to everyone. Nan R kantilva. E kanta? Yes. Directly proportional. Third point, directly proportional to the number of the turns of the coil. Number of the turns of the coil. So, its M is actually inversely, directly proportional to the number of the turns of the coil. Turns of the coil. Then, clear everyone? So, ಈ ಮೂರು points ನೆನಪಿಟ್ಕೊಳ್ಳಿ ಆಯ್ತಾ ಈ ಮೂರು points ನೆನಪಿಟ್ಕೊಳ್ಳಿ that is the magnitude of the magnetic field at the center of the coil how it will behave. These are the 3 points which you people need to remember. Clear? Magnetic field due to the current carrying circular coil. You understand ಆಯ್ತಾ? This is very important. Okay, ಇದನ್ನ ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್ ಮಾಡ್ಕೊಂಡ್ರೆ ಪ್ರಾಬ್ಲಮ್ಸ್ ಈಸಿಯಾಗಿ ಗೊತ್ತಾಗುತ್ತೆ. ಪ್ರಾಬ್ಲಮ್ಸ್ ಈಸಿಯಾಗಿ ಗೊತ್ತಾಗುತ್ತೆ. Yes. Next comes what? Magnetic field due to the current carrying solenoid. Current carrying solenoid. So the pattern of the magnetic field lines around whatever the pattern is there, okay? The pattern of that magnetic field lines around the current carrying solenoid is similar to that of produced by bar magnet as shown in the figure below. So it's shown in the figure below how it's been forming. Just observe it properly everyone. So how it's been forming? This is a bar magnet which is present. Okay, this is a bar magnet which is present. It's in this way. ಇದೆಲ್ಲ ಬ್ಯಾಟ್ರಿ ಆಮೇಲೆ ಇದು ಕೀ ಬರುತ್ತೆ ಇದು ಪಾಸಿಟಿವ್ ಇದು ನೆಗೆಟಿವ್ in this way the rings are being forming. Okay, this way the rings are being forming. Okay, in the current ಬರ್ದಿದೆ the lines of the magnetic field how it has been there. These are the lines of the magnetic field, but electricity ಹೇಗೆ ಪಾಸ್ ಆಗ್ತಿದೆ ಇದೇ ತರ ಪಾಸ್ ಆಗ್ತಿದೆ electricity. Like this it's going, it is going like this. Okay, ಈ ತರ ಆಗ್ತಿದೆ. So the pattern of the magnetic field lines around the current carrying solenoid, which is the current carrying solenoid, there is a similar to that produced by a bar magnet. Produced by a bar magnet. That is known as what? Magnetic field. Clear everyone? Next, the magnetic field inside a solenoid is uniform. So the magnetic field inside the solenoid is completely uniform. Uniform means what? The magnetic lines which are present on that solenoid, that will be all lines will be at a proper lines. Okay, uniform lines. Okay, there will be not be like a waves. ಮೇಲೊತ್ತು ತಳಗೊತ್ತು ಅದೆಲ್ಲ ಆಗಲ್ಲ ಅಲ್ಲಿ ಓಕೆತಾ ಆಯ್ತಾ. ನೆಕ್ಸ್ಟ್ in accordance. So, in accordance with the clock rule, the end of the solenoid at which the current flow is anti-clockwise. So, end direction will be what? Anti-clockwise. Okay, it will be anti-clockwise direction, which will behave as the north pole. It will behave like what? It will behave like a north pole, while the end which the current flows in the clockwise direction behaves has a south pole. It will behave like how? It will behave like a south pole. Clear? Now the magnitude of the magnetic field, inside the solenoid is directly proportional to current flowing through it, Next, the number of the turns per unit of the solenoid, the number of the units per unit of the solenoid. Now concentrate properly. Okay, so yeah, the magnitude means the direction which is there, that the direction magnetic field which is present inside. Okay, inside the solenoid, inside the means it is solenoid, inside the solenoid which is present is directly proportional to the current. Yav current flow ಆಗ್ತಿದೆ. Okay, yav direction alli matte yav current flow ಆಗ್ತಿದೆ, yav direction alli, that is very important. Those both are proportional. Okay, yav current pass ಆಗ್ತಿದೆ ಮತ್ತು yav ತರ ಆಗ್ತಿದೆ ಅದು important. ಆಯ್ತಾ? So that is current flowing through it at what direction? At what direction? Clear? The number of the turns per unit length of the solenoid, it is also directly proportional to the number of the turns. How much the turns per unit length? Per unit length ಮೇಲೆ ಎಷ್ಟು turns ಆಗಿದೆ solenoid ಗೆ. Means here the turns which are present, the coil which is getting rotated, ಏನು ತೆಗೆದಿದ್ದಾನಲ್ಲ ಅವು ಎಷ್ಟಾಗಿದೆ per unit length ಗೆ ಎಷ್ಟು convert turn ಆಗಿದೆ, how much you have rotated it, that is also very important. Clear? Next, force on a current carrying conductor in a magnetic field. What are the forces on a current carrying conductor that in a magnetic field? So first is what? A current carrying conductor when placed in a magnetic field will experience a force. So whatever the current carrying conductor is there, when passed in the magnetic field, when it is being passed in the magnetic field, experiences a force. It will experience what? It will experience a force. That you people need to remember. Okay, so the current which is carrying a conductor, when passed through the magnetic field, it will experience a force. So ಹೇಗೆ ಎಕ್ಸ್ಪೀರಿಯನ್ಸ್ ಆಗುತ್ತೆ ಫೋರ್ಸ್? ಒಂದು ಸಿಂಪಲ್ ಎಕ್ಸಾಂಪಲ್ ಹೇಳ್ತೇನೆ. ಈಗ ಯಾವುದೋ ಒಂದು ಮ್ಯಾಗ್ನೆಟ್ ತಗೊಂಡಿದ್ದೀರಾ, 2 magnets you have taken it, just imagine this 2 are the magnets. So these are far right now, there will be no force between them. Whenever it comes near to the magnetic field, okay, this is south, this is north, you think, okay, ಯಾವಾಗ ನಾ ಹತ್ರ ತಗೊಂಡು ಬರ್ತೀನಿ, it will make me to just, it will go and attach. Okay, ಇಲ್ಲಿರುತ್ತದು, but it will go and attach. Why? The force, because of the force. Clear? So ಇದು ನೀವು ಎಕ್ಸ್ಪೀರಿಯನ್ಸ್ ಮಾಡಿರಬೇಕು ಆಲ್ರೆಡಿ. ಆಯ್ತಾ? Now next is what? The direction of a force get reversed when the direction of the current is reversed, or when the direction of the magnetic field is reversed. So it depends on what? The direction of a force gets reversed. The direction, whatever the direction I am coming in, it will get reversed also. If in the case when the direction of the current is reversed, or when the direction of the magnetic field is reversed. Like example, magnetic field is being only reversed and the current is only not getting passed when it is needs to have a force, it will not happen. Simple. That's it. Right? Next, the force acting on a conductor, whatever the force which is acting on the conductor is found to be maximum when the current and the magnetic field, it is going to be maximum. Whatever the conductor is being forming there, that is going to be the maximum. That is going to be the maximum when the current and the magnetic field are at the right angle to each other. Whenever they are at the right angle to each other, there will be a force acting on a conductor. That force will be acting maximum when there will be a passage of the current and the magnetic field at the right angle to each other. At a right angle. So, ಈಗ ನಾನು ಯಾವಾಗ ಇನ್ಸಿಡೆಂಟ್ ಮತ್ತು ರಿಫ್ಲೆಕ್ಟೆಡ್ ರೇಡಿಯೋ ರೈಟ್ ಆಂಗಲ್, ಬಿಕಾಸ್ ಅಕಾರ್ಡಿಂಗ್ ಟು ದ ನಾರ್ಮಲ್ ರೇ ಇರುತ್ತಲ್ಲ ಅವಾಗಷ್ಟೇ ಆಗೋದು. ಆಯ್ತಾ? ನೆಕ್ಸ್ಟ್, when the conductor is placed parallel to the magnetic field, no forces acts. So whenever the conductor is being placed parallel, so ಯಾವಾಗ ಕಂಡಕ್ಟರು ಪ್ಯಾರಲಲ್ ಆಗಿರುತ್ತೆ, ಇದು ಒಂದು ಮ್ಯಾಗ್ನೆಟು, ಇದು ಕರೆಂಟು, ಸೊ ಪ್ಯಾರಲಲ್ ಆಗಿದ್ರೆ they will not act. Means what? There will be no force on it. No force, guys. How the force will be there? I told you people, force ಯಾವಾಗ ಬರುತ್ತೆ? ನಾರ್ತ್ ಪೋಲ್ ಸೌತ್ ಪೋಲ್ ಇದೆ, ಯಾವಾಗ ಇರುತ್ತೆ ಫೋರ್ಸು? ಇಲ್ಲಿ ಫೋರ್ಸ್ ಇದು, ಇವೆಲ್ಲ ಫೋರ್ಸು. ಸೊ ಹೀಗಿದ್ರೆ ಹೇಗೆ ಪ್ಯಾರಲಲ್ ಇದ್ರೆ ಹೇಗೆ ಫೋರ್ಸ್ ಆಕ್ಟ್ ಆಗುತ್ತೆ? ರೈಟ್, ಅಟ್ ಲೀಸ್ಟ್ ಇಟ್ ಶುಡ್ ಬಿ ಲೈಕ್ ದಿಸ್, ರೈಟ್? ದೆನ್ ಓನ್ಲಿ ದ ಫೋರ್ಸ್ ವಿಲ್ ಆಕ್ಟ್ ದೇರ್. ಕ್ಲಿಯರ್? ತಿಳಿತಾ? ಎಸ್. ನೆಕ್ಸ್ಟ್ ಕಮ್ಸ್ Fleming's left hand rule, which gives the direction of the magnetic force acting on the conductor. So this is our Fleming's left hand rule. This is what? Fleming's left hand rule. ಕರೆಕ್ಟ್ ಬರದೆ ಅಲ್ಲ ನಾನು INGS ಬರುತ್ತೆ ಜಿ ಒಂದು ಎಕ್ಸ್ಟ್ರಾ ಬರೆದ್ಬಿಟ್ಟೆ ನಾನು Okay, Fleming's left hand rule. So let's understand this Fleming's left hand rule right now. So ಈ ಮನುಷ್ಯ ಗೊತ್ತು ಕಾಣ್ತಿದಾನ ಇಲ್ಲ ನನಗೆ ಗೊತ್ತಿಲ್ಲ ಬಟ್ ಲಿಟಲ್ ಬಿಟ್ adjust. I'll write it if you people want it. Thumb motion. Okay, ಇದೇನು field. Okay, magnetic field. This is current. This is going to be the current. Now, how it's been acted? This is the force which is coming. This is the force which is coming. This is the field which is coming. And this is the current which is coming. Okay. This is the current which is coming. Current and the index field. Okay. Index field. Here, how it is been acting. Il ತಗೊಂಬರಲ್ಲ. Okay. ಈ ತರ ಆಕ್ಟ್ ಆಗ್ತಿದೆ. ಇಲ್ಲಿ ಚೆನ್ನಾಗಿ ನೋಡ್ಕೊಳ್ಳಿ. ಇದೇನು ಗೊತ್ತಾ? Thumb which is acting like what? Thumb is a thumb motion. Thumb is actually like force. Illinda force ಹೋಗ್ತಿದೆ. Okay, this is the force. This is what? The field, magnetic field. The force is entering the magnetic field and this is what? Index finger ಏನಾಗುತ್ತಪ್ಪ? Middle finger ಏನಾಗುತ್ತೆ? Middle finger is going to be what? Current. Middle finger is going to act like a current. This is the Fleming's left hand rule. Because Fleming's told in this way, you people can easily remember where the electricity is been passing, how the magnetic field is acting, how the force is been acting. So this will be very easy to remember, right? Thumb andre enappa? Thumb means what? Thumb means force. Okay, thumb andre enu? Force. Thumb means force. ಕರೆಂಟ್ ಅಂದ್ರೆ ಏನು? ಕರೆಂಟ್ ಅಂದ್ರೆ ಯಾವ ಕೈಯು? ಯಾವ ಬಟ್ಟು? ಮಿಡಲ್ ಫಿಂಗರ್. ಓಕೆ, ಫೀಲ್ಡ್ ಅಂದ್ರೆ ಏನು? ಫೀಲ್ಡ್ ಇಸ್ ಇಂಡೆಕ್ಸ್ ಫಿಂಗರ್. ಓಕೆ, ಇಂಡೆಕ್ಸ್ ಫಿಂಗರ್. Clear? This much you people remember. Fleming's left hand rule will be very easy. So ಅದರ ಮೇಲೆ ನೋಟ್ ಬರ್ಲಿಕ್ಕೆ ಹೇಳಿದ್ರು ನೀವು ಆರಾಮಾಗಿ ಎಕ್ಸ್ಪ್ಲೇನ್ ಮಾಡ್ಬೋದು. ಫೋರ್ಸ್ ಎಲ್ಲಿಂದ ಅಪ್ಲೈ ಆಗುತ್ತೆ, ಕರೆಂಟ್ ಎಲ್ಲಿಂದ ಬರುತ್ತೆ, ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಎಲ್ಲಿರುತ್ತೆ, ಅವೆಲ್ಲ ಈಸಿಯಾಗಿ ಗೊತ್ತಾಗುತ್ತೆ. ಕ್ಲಿಯರಾ? ಅಂಡರ್ಸ್ಟುಡ್? Next, Fleming's left hand rule, that is stretch the thumb. They have explained it that only. Stretch the thumb and forehand and middle finger of the left hand rule such that they are mutually perpendicular to each other if the first finger points, that is the first finger points such that they are mutually perpendicular to each other. If the first finger points the direction of the field and the middle finger in the direction of the current, then the thumb gives the direction of the motion or the force acting on the conductor or the force acting on the conductor. Same way I explained it. Fleming's left hand rule ಅನ್ನ ಚೆನ್ನಾಗಿ ಎಕ್ಸ್ಪ್ಲೇನ್ ಮಾಡ್ಬೇಕಂದ್ರೆ 4 ರಿಂದ 5 ಪಾಯಿಂಟ್ ಮಾಡಿ ಈಗ ಬುಕ್ ತಗೊಂಡು ಕುಂತು ಅದನ್ನ ಬರೆದು ಮಾಡಿ ಅದನ್ನ ಪಾಯಿಂಟ್ಸ್ ಅನ್ನ ಇನ್ ಕೇಸ್ ನೋಟ್ ಅಂತ ಕೇಳಿದ್ರೆ you people can easily answer it. Clear everyone? Yes. Next, the force experienced by the current carrying conductor in a magnetic field in a magnetic field is underlying principle of electric motor, is underlying principle of electrical motor where electrical energy is converted into mechanical energy. It is converted where electrical energy into mechanical energy it will be converted. Electrical energy directly mechanical energy ಹೇಗೆ ಕನ್ವರ್ಟ್ ಆಗುತ್ತೆ? ಯಾವಾಗ ನಾವು electricity ಮತ್ತೆ magnetic field equal means whatever we learned it no, according to that it will be converted to the mechanical energy. Okay, so only mechanical energy ಅಂದ್ರೆ ಏನು? ಯಾವ್ದಾದ್ರು ಒಂದು ಮಷೀನ್ ಇದೆ ಅಪ್ಪ, ಓಕೆ, ಮೆಕ್ಯಾನಿಕಲಿ ವರ್ಕ್ ಆಗ್ತಿದೆ, ಏನೋ ಒಂದು ಮಾಡಿ ಕೊಡ್ತಿದೆ, ಹೇಗೆ ಫಾರ್ಮ್ ಆಗುತ್ತೆ? ಬಿಕಾಸ್ ಆಫ್ ದ ಫ್ಲೆಮಿಂಗ್ಸ್ ಲೆಫ್ಟ್ ಹ್ಯಾಂಡ್ ರೂಲ್. Clear? Next, such motors are used to run the electrical appliances including fans and the toys. Right now the AC is also working here, so the AC is also ಹೇಗೆ work ಆಗುತ್ತೆ ಇದೇ ತರ. Done. So this is how the rules you people need to remember. Fellings left hand rule ನಾವು ಬಹಳ ಯೂಸ್ ಮಾಡ್ಕೋತೇವೆ, ಇವಾಗಿನ ತನಕ ನಿಮಗೆ ಗೊತ್ತಿರಲಿಲ್ಲ ಅಂದ್ರೆ ಈಗ ಗೊತ್ತು ಮಾಡ್ಕೊಳ್ಳಿ, because this is very basic thing to remember. ಆಯ್ತಾ? Next comes what? Electromagnetic induction. Electromagnetic induction ಮೇಲೆ short ಒಂದು question ಬೀಳುತ್ತೆ. Okay? Sorry. Done? Now, first is what? The phenomenon of generating an electrical current in a circuit. So, in a circuit, if the phenomenon, the current is being getting generated, that is by the coil, by changing the magnetic flux which is being linked with it is called as electromagnetic induction. Clear? So, how it is being formed? Generating the electrical current. A current is being generated, okay? And in the circuit, by changing the magnetic flux. So, by changing the magnetic flux, the electricity is being generated, which has been linked with what? It is being linked is called as electromagnetic induction. It has been linked with, it is called as electromagnetic conduction. So, electromagnetic induction is also very important. ಈ definition ಮೇಲೆ 2 marks ಕೇಳ್ತಾರೆ. Electromagnetic induction 2 marks. 2 marks ಅಂದ್ರೆ ಎಷ್ಟು ಓದಬೇಕು ನೀವು? ಜಸ್ಟ್ ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್ ಮಾಡ್ಕೊಂಡ್ರೆ ಸಾಕು. ಆಯ್ತಾ? ಹೆಂಗೆ ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್ ಮಾಡ್ಕೊಂಡು? whenever the phenomenon is generating the electrical current, ಯಾವಾಗ electrical current is being generated, that time in the circuit electrical current ಎಲ್ಲಿ ಜನರೇಟ್ ಆಗ್ತಿದೆ? ಸರ್ಕಿಟ್ ಮೇಲೆ. ಸರ್ಕಿಟ್ ಎಲ್ಲಿ ಆಗುತ್ತದೆ? ಸರ್ಕಿಟ್ ಎಲ್ಲಿದೆ? ಕಾಯಿಲ್ ಎಲ್ಲಿದೆ? ಅಲ್ಲಿ ಸರ್ಕಿಟ್ ಆಗ್ತಿದೆ, ಸರ್ಕಿಟ್ ಇದೆ, ರೈಟ್? ಬೈ ಚೇಂಜಿಂಗ್ ದ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫ್ಲಕ್ಸ್, magnetic flux can link ಆಗಿರುತ್ತಲ್ಲ, by changing it with that we called as electromagnetic conduction, sorry, induction. Okay? Now, the change in the magnetic flux in the coil may be due to, why this change in the magnetic flux? ಈ definition ಕಲ್ತ್ವಿ. ಆ definition ಅಲ್ಲಿ ಆ magnetic flux ಎದಕ್ಕೆ change ಆಗ್ತಿದೆ ಲಿಂಕ್ ಆದಾಗ ಅದು ಇಂಪಾರ್ಟೆಂಟ್ ಇದೆ, right? Now, why it is changing is the relative motion between the coil and the magnet placed near it. The relationship between the coil ಮತ್ತೆ magnet ದು ಏನ್ ಪ್ಲೇಸಿಂಗ್ ಇರುತ್ತಲ್ಲ ಅದ್ರ ಸಲುವಾಗಿ ಅದು ಚೇಂಜ್ ಆಗ್ತಿದೆ. This is the first one. Sorry. Okay. Next comes what? Relative motion between the coil and the current carrying conductor placed near to it. So, whatever the coil, ಇಲ್ಲಿ ಏನು coil circuit ಇದೆಯಲ್ಲ, ಅಲ್ಲಿ ಏನು coil ಇದೆಯಲ್ಲ, that and the current carrying conductor, ಯಾವ current ಪಾಸ್ ಆಗ್ತಿದೆ, ಎಲೆಕ್ಟ್ರಿಸಿಟಿ ಯಾವ್ದ್ರಿಂದ ಪಾಸ್ ಆಗ್ತಿದ್ದಿಲ್ಲ ಅದು ಕಂಡಕ್ಟರ್. ಆಯ್ತಾ? ದೇ ಆಲ್ ಆರ್ ನಿಯರ್ ಟು ಇಟ್. ದೇ ಆಲ್ ಆರ್ ನಿಯರ್ ಟು ಇಟ್. ನೆಕ್ಸ್ಟ್, change of the current in the conductor which is being placed near the coil. Okay, the change of the current conductor that is very much nearer, means placed nearer to the coil. Next, Phelan's right hand rule is being used to find the direction of the induced current. It is being used for the direction of the induced current. It is for the direction of the induced current. Clear? Clear? Next, so this is how you people need to remember. Concentrate properly now. Ee tara. This is how it's going to be remembered. This is I'm using left, right hand, right? I should be like this. Okay, I don't know how it will look in the camera actually. Okay, so illenide obban manshan ididare. This is the movement of the current. Thumb is going to act like what? Movement of the conductor. Thumb's work enadu? Movement of conductor. Understood? Next comes what? Current induced in the conductor. Current induced in conductor. In conductor, current is being induced in the conductor. Next, this index finger is actually called as what? Magnetic field. It's called as what? Magnetic field. So in this way you people need to remember. Concentrate properly. Idu field, idu motion, this is the motion, and this is the induced current, and this is the induced current. This much you people remember, it's enough. Okay. Now, Film's right hand rule: stretch the thumb, forefinger and the middle finger at the right hand such that they are mutually perpendicular to each other. They are mutually perpendicular to each other in this way. Okay, they are mutually perpendicular to each other. Now, where it went? Yes, if the forefinger points the direction of the field, if the forefinger or index finger, index ಅಂತಾನೆ ಕರೀತಾರಲ್ಲ ಇದಕ್ಕೆ, ನಾನು ಕನ್ಫ್ಯೂಸ್ ಆಗ್ತಿದೆ. So ಈ forefinger ಅದರ index finger which is present actually where field, and the thumbs in a where forefinger points the direction of the field. So his four fingers will point the direction of the field and the thumb in the direction of the motion. This thumb is a motion, this is the forefinger and of the conductor, and the middle finger gives the direction of the induced current in the conductor. Induced current in the conductor. So this is induced current in the conductor. Clear? So this is how Film's right hand rule you people need to remember. This is also very important, guys. Must do. Next, electrical generator. Electrical generator andre eno? The electrical generator is based on the principle of electromagnetic induction. It's placed in the form of what? Electromagnetic induction, and converts the mechanical energy into electrical energy. It will convert what? It will convert the mechanical energy into the electrical energy. So mechanical energy the electrical energy gain convert ಆಗ್ತದಲ್ಲ ಅದಕ್ಕೆಲ್ಲ electrical generator ಅಂತ ಕರೀತಾರೆ. So electromagnetic induction. Okay. Electromagnetic induction principle means principle ಅದು ಸೇಮ್ ಇದೆ. electromagnetic induction ಹೇಗಿದೆಯಲ್ಲ ಅದೆಲ್ಲ ಸೇಮ್. Just the thing is it will convert the mechanical energy into the electrical energy. Clear? Electrical generator also ಮೇಲೇನು question ನೀವು ಕೇಳ್ತಾರೆ. Important. Next, there are two types of generators. We have two types of generators. First one is what? AC generator, which is producing a current which periodically changes its direction. Periodically, if the AC generator is producing the current, which will periodically, slowly it will change its current. Second, DC generator producing the current which always flow in the same direction. It always flows in the same direction. DC andre enu direct current. Okay. AC andre enu alternative current. AC and DC, that is very very important. Okay. Next, an AC generator can be changed into DC generator, and AC generator can be converted into the DC generator, which is by replacing the slip ring arrangement with the split ring arrangement commutator. Okay, with the split ring arrangement commutator. Clear? Understood? Understanding? So electrical generator ಮೇಲೇನು ಬಹಳ ಕ್ವಶನ್ ಕೇಳ್ತಾರೆ. ಇದ್ರ ಮೇಲೇನು ಇಂಪಾರ್ಟೆಂಟ್ ಇದೆ, ಮಸ್ಟ್ ಡು. ಆಯ್ತಾ? ಎಲೆಕ್ಟ್ರಿಕಲ್ ಜನರೇಟರ್ ಇಸ್ ವೆರಿ ವೆರಿ ಇಂಪಾರ್ಟೆಂಟ್. ಇದ್ರ ಮೇಲೇನು ಬಹಳ ಕ್ವಶನ್ಸ್ ಕೇಳ್ತಾರೆ, ಚೆನ್ನಾಗಿ ಕುಂತು ಓದಿ. ಆಯ್ತಾ? ನೆಕ್ಸ್ಟ್ ಕಮ್ಸ್ ವಾಟ್? ಎಸ್, domestic electric circuits. So what is the domestic electrical circuits? ಹೇಗೆ ನಿಮ್ಮ ಮನೆಯಲ್ಲಿ electrical circuits ಹೇಗೆ ಕನೆಕ್ಟ್ ಇರುತ್ತೆ, ಹೇಗೆ ಮಾಡ್ತಾರೆ ಅದನ್ನೆಲ್ಲ ಇವತ್ತು ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್ ಮಾಡ್ಕೊಳ್ಳೋಣ. ಆಯ್ತಾ? So in our house or homes we receive the electrical power through the main supply called as mains. Okay, we receive an AC electrical power. So AC means not a direct current, it is alternative current. Okay, of our electrical power of how much volt? 220 volt with a frequency of 50 hertz. With a 220 volt with a frequency of a 50 hertz. So 220 volt depends on how huge the home is. If in case bad the home ittandre ಜಾಸ್ತಿ ಬರುತ್ತೆ volt, it's not like only 220 volt will be present. Clear? How those arrangements will be done, that we are going to learn it. So now, one of the wires in the electricity wiring of the house has red insulation, and it is called as what? Live wiring. It is called as what? Live wiring. Clear? And the other of the black, that is about the black insulation, it is called as what? Neutral wire. The black insulation is actually called as what? Black insulation is going to be what? That is going to be the neutral wire. That is going to be the neutral wire. Now the third is the earth wire, which has green insulation. Third is what? It is going to be the green insulation, that is earth wire. Green insulation is called as what? Earth wire. Illa green is earth wiring. Okay. Next comes, and it is connected to the metallic plate deep inside the earth. So here the metallic plate will be present. In there the connection will be done. Clear? Now concentrate properly everything. One more time I am explaining the same thing. The green color is earth wire. Okay, this all are called as earth wire. So this whatever is there, that is live wire. Okay, idella live wire transfer agtide electricity allinda. So next neutral wire, black thing which is present, that is going to be the neutral wire. So this is a distributor box, how it is being distributed to the other places. Okay, means room, bedroom, hall, dining hall, like that. Okay, electricity meter which will be present in your home at the entry or somewhere. Okay, electrical one box tara irutte, alli one switch on madodu off madodu adradella irutte. Aita? So this is 220 volt, how it is being transferred, and here the earthing is being done. So elladukku earthing important ide. So earthing irlilla andre sariyagi electricity pass agalla, fluctuations irutte. There will be a chances that a person might get an electrical shock also. Clear? So the earthing is very, very important. Done? Next comes what? The earth wiring is used as a safety measure to ensure that any linkage, that is what I told, leakage of the current in the metallic body does not give the user a severe shock. Does not give the body a severe shock. Clear? Next, a fuse is an important safety device which is used to protect the circuits and appliances, that is short circuiting, which occurs when live wire and a neutral wire come in contact. Live wire and the contact wire, if both the things, okay, short circuit yavaga, which is going to be across when the live wire and a neutral wire comes in contact. Live wire ಇದು ಲೈವ್ ವೈರು, ಇದು ನ್ಯೂಟ್ರಲ್ ವೈರ್. ಇಲ್ಲಿ ನೋಡಿ ಇಲ್ಲೇ ಇದೆ ಅಲ್ಲ, ಇವು ಎರಡು ಅಕಸ್ಮಾತ್ ಕಾಂಟ್ಯಾಕ್ಟ್ ನಲ್ಲಿ ಬಂದ್ರೆ, ಇಫ್ ಇನ್ ಕೇಸ್ ದೋಸ್ ಬೋತ್ ದ ಥಿಂಗ್ಸ್ ವಿಲ್ ಗೆಟ್ ಇನ್ ಕಾಂಟ್ಯಾಕ್ಟ್, ವಿ ವಿಲ್ ಗೆಟ್ ವಾಟ್? ಶಾರ್ಟ್ ಸರ್ಕ್ಯೂಟ್. Will get what? If in case the live wire and the neutral wire will get connected, we will get the short circuit. Clear? We will get the short circuit. Understood? Ee point ನೆನಪಿಟ್ಕೊಳ್ಳಿ, ಇದು points ಅನ್ನ ಕೇಳ್ತಾರೆ. Next, a fuse is a important safety device used to protect the circuit and the appliances, that is short circuit and or overloading which occurs when an electrical circuit draws more current than the permitted value. It draws more current than the permitted value. Okay, draws more current ಅಂದ್ರೆ ಏನು? 220 volt limit ಇದೆ ಅಪ್ಪ, ಆಯ್ತಾ? ಸೊ ಆ 220 volt ಗಿಂತ 500 volt ಆಯ್ತು. ಓಕೆ, 220 volt limit ಇದೆ. Okay, it's a limit of 220 volt. But if in case it's drawing 550 volt, okay, it's drawing means it is called as what? Overloading. ಎಷ್ಟು draw ಮಾಡ್ತಿದೆ? If it is drawing this much, then it is called as what? Overloading. There will be a possibility of the overloading. So overloading ಆದ್ರೆ ಏನಂತಾರೆ ಹೇಳ್ತಾರಲ್ಲ, ಶಾರ್ಟ್ ಸರ್ಕ್ಯೂಟ್ ಆಯ್ತು, ಟಿವಿ ಒಮ್ಮೆ ಸಡನ್ಲಿ ಬಂದ್ ಆಗ್ಬಿಡ್ತು, ಸ್ಕ್ರೀನ್ ಒಮ್ಮೆ ಸಡನ್ಲಿ ಬಂದ್ ಆಗ್ಬಿಡ್ತು. ಸೊ ಇವೆಲ್ಲ ಆಗೋದು ಓವರ್ಲೋಡಿಂಗ್ ಇಂದ. ಸೊ ಅದಕ್ಕೆ ಸ್ಟೆಬಿಲೈಸರ್ ಯೂಸ್ ಮಾಡ್ತಾರೆ. ಸೊ ಮೊದಲು ಸ್ಟೆಬಿಲೈಸರ್ಸ್ ಬಾಕ್ಸ್ ತರ ಇರ್ತಿತ್ತು, ಈಗ ಏನಾಗಿದೆ ಅಂದ್ರೆ ಸ್ಟೆಬಿಲೈಸರ್ಸ್ ಆರ್ ಆಕ್ಚುಲಿ ಆಟೋಮೆಟಿಕ್ಲಿ, ಅಂದ್ರೆ ಅದ್ರಲ್ಲೇನೆ ಇನ್ಸೈಡ್ ಅಲ್ಲೇ ಕವರ್ ಮಾಡ್ಕೊಂಡ್ಬಿಡ್ತಿದ್ದಾರೆ ಈಗ. ಓಕೆ, ಫಸ್ಟ್ ಫ್ರಿಡ್ಜ್ಗೆ ಮತ್ತೆ ಟಿವಿಗೆ ಅವಕ್ಕೆಲ್ಲ ಸ್ಟೆಬಿಲೈಸರ್ ಹಾಕ್ತಿದ್ರು, ಬಿಕಾಸ್ ಸಮ್ ಟೈಮ್ಸ್ ದೇರ್ ವಿಲ್ ಬಿ ಅ ಓವರ್ಲೋಡಿಂಗ್ ಆಲ್ಸೋ. ಅದ್ರ ಸಲುವಾಗಿ ಸಲುವಾಗಿ ಅದು ಸ್ಟೆಬಿಲೈಸರ್ ಕಂಟ್ರೋಲ್ ಮಾಡುತ್ತೆ. ಕಂಟ್ರೋಲ್ ಅಂದ್ರೆ ಏನು, ನಾ ಎಷ್ಟು ಫ್ರಿಡ್ಜ್ ಕರೆಂಟ್ ಬೇಕಲ್ಲ ಅಷ್ಟೇ ಹೋಗೋದು, ಟಿವಿಗೆ ಎಷ್ಟು ಕರೆಂಟ್ ಬೇಕಲ್ಲ ಅಷ್ಟೇ ಹೋಗೋದು, ಅದೆಲ್ಲ ಮಾಡ್ತಿತ್ತು. ಬಟ್ ಈಗ ಏನು ಪ್ರಾಬ್ಲಮ್ ಆಯ್ತಂದ್ರೆ ಈಗ ಎಲ್ಲ ಇನ್ಸೈಡ್ ಟೆಕ್ನಾಲಜಿ, ಸೊ ಎಲ್ಲ ಮಷೀನ್ ನಲ್ಲಿನೇ ಆಗ್ತಿದೆ. ಕ್ಲಿಯರಾ? Next comes what? Why does a campus? Okay, we have some questions right now. Okay, till then everyone understood this questions? Everything understood? Yes. So each chapter ಸ್ವಲ್ಪ ಸೊ ಈ ಚಾಪ್ಟರ್ ಸ್ವಲ್ಪ ಡಿಫಿಕಲ್ಟ್ ಆಗುತ್ತೆ ಸ್ವಲ್ಪ ಮಂದಿಗೆ, ಬಟ್ ದಿಸ್ ಇಸ್ ಆಕ್ಚುಲಿ ಇಫ್ ಐ ಟೆಲ್ ಯು ದೆನ್ ಈಸಿಯಸ್ಟ್ ಚಾಪ್ಟರ್. ಓಕೆ, ಈಸಿಯಸ್ಟ್ ಚಾಪ್ಟರ್ ಇದು. ಸೊ ಯು ಪೀಪಲ್ ನೀಡ್ ಟು ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್ ಇಟ್ ಪ್ರಾಪರ್ಲಿ, ದೆನ್ ಓನ್ಲಿ ಯು ಪೀಪಲ್ ಕ್ಯಾನ್ ಆನ್ಸರ್ ದಿಸ್ ಕ್ವಶನ್ಸ್. ಓಕೆ, ಸ್ವಲ್ಪ ಕ್ವಶನ್ಸ್ ತಗೊಂಡಿದ್ದೀನಿ ಈ ಚಾಪ್ಟರ್ ಮೇಲೆನೆ, ಇಲ್ಲೇ ಎದಕ್ಕಂದ್ರೆ ನಿಮಗೆ ಯಾವ ಥರ ಕ್ವಶನ್ಸ್ ಕೇಳ್ತಾರೆ ಅನ್ನೋದು ಒಂದ್ಸಲ ಹೇಳ್ಕೊಡ್ತೇನೆ, ಸೊ ದ್ಯಾಟ್ ಯು ಹ್ಯಾವ್ ಅ ಐಡಿಯಾ ದಟ್ ಈ ಥಿಯರಿಯನ್ನು ಓದ್ಕೊಂಡ್ರೆ ಈ ಕ್ವಶನ್ಸ್ನ ಪರ್ಫೆಕ್ಟಾಗಿ ಆನ್ಸರ್ ಮಾಡಬಹುದು. Till then everyone are clear till here? So first ಏನು ತಗೊಂಡ್ವಿ, ಡೊಮೆಸ್ಟಿಕ್ ಎಲೆಕ್ಟ್ರಿಕಲ್ ಸರ್ಕ್ಯೂಟ್ ದಿನ ಭಾಳ ಕ್ವಶನ್ಸ್ ಕೇಳ್ತಾರೆ. ಎಲೆಕ್ಟ್ರಿಕಲ್ ಜನರೇಟರ್ ಮತ್ತು ಅದ್ರ ಯೂಸಸ್ ಮೇಲೆ ಕ್ವಶನ್ಸ್ ಭಾಳ ಕೇಳ್ತಾರೆ. ಯೂಸಸ್ ವಿಲ್ ಬಿ ಆಸ್ಕ್ಡ್ ಅ ಲಾಟ್. ಓಕೆ, ಇದರದ್ದು ಯೂಸಸ್ ಆ್ಯಂಡ್ ಇಟ್ಸ್ ಇಂಪಾರ್ಟೆಂಟ್. ಆಯ್ತಾ? Yes, let's see the questions then. First question, why does a campus needle get deflected when brought near the bar magnet? Campus needle ಎದಕ್ಕೆ ಡಿಫ್ಲೆಕ್ಟ್ ಆಗುತ್ತೆ ಯಾವಾಗ ನಾವು ಬಾರ್ ಮ್ಯಾಗ್ನೆಟ್ ಕಡೆ ತೊಗೊಂಬರ್ತೇವೆ? It is because of the magnetic field lines. ಯಾವ ಲೈನ್ಸ್ ಇದೆಯಲ್ಲ ಅದ್ರ ಪ್ರಕಾರ, ರೈಟ್? The magnetic field of the magnet exerts more force. It will exert a more force on both the poles of the compass needle, and the forces experienced by the two people are equal and opposite. By the two people are actually equal and it is opposite. Clear? And these two forces forms the couple which deflects the compass needle. In this way the compass needle will be deflecting. So ಇಲ್ಲಿ ತಿಳ್ಕೊಳ್ಳಿ, ಇದು ಬಾರ್ ಮ್ಯಾಗ್ನೆಟ್ ಇದೆ. Okay, this is our bar magnet, you think. Okay, it's not square. Let me see the rectangular where it is. Okay, I'm not getting any rectangular. ಇಲ್ಲಿ ನಾವೇ ಡ್ರಾ ಮಾಡ್ಕೊಂಡ್ಬಿಡೋಣ. ಇದು ಬಾರ್ ಮ್ಯಾಗ್ನೆಟ್. ಓಕೆ, ಸೊ ಇದು ಬಾರ್ ಮ್ಯಾಗ್ನೆಟ್ ಅಲ್ಲಿ ಇದು ನಾರ್ತ್ ಪೋಲು, ಇದು ಸೌತ್ ಪೋಲು. ಆಯ್ತಾ? ಈ ನಾರ್ತ್ ಪೋಲು ಮತ್ತು ಸೌತ್ ಪೋಲು ಕಂಪಸ್ ಯಾವಾಗ ನಾವು ಈ ಕಂಪಸ್ನ ಯಾವಾಗ ನಾವು ನಾರ್ತು ಸೌತು ಈ ಕಂಪಾಸ್ನ ಯಾವಾಗ ತಗೊಂಡ್ ಬರ್ತೇವಲ್ಲ ಇದ್ರ ಕಡೆ, ಈ ತಂದಾಗ ಏನ್ ಡಿಫ್ಲೆಕ್ಟ್ ಆಗುತ್ತೆ ಅಕಾರ್ಡಿಂಗ್ ಟು ದ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಲೈನ್ಸ್ ಇಟ್ಸ್ ಗೋಯಿಂಗ್ ಟು ಡಿಫೆಕ್ಟ್. Clear? That is actually called as what? Why does the compass needle will deflect? Because of the magnetic lines which are present nearer to the pole, not at the between. It is not present at the between. It's nearer to the pole. Clear? Next question. List the properties of magnetic lines of a force. So they have told us to list the properties. Na ivaga kalstide alla avagunu helidde nimage idu baala important anodu. Right? I have told you, right? This question is important anta helidde alla. ಸೊ ಇದು ಇಂಪಾರ್ಟೆಂಟ್ ಅಂತ ಹೇಳಿದೆ ಅಲ್ಲ. ಸೊ ಇದು ಈಗ ಕೇಳಿದ್ದಾರೆ, ಈ ಟೈಪ್ ಆಫ್ ಕ್ವಶನ್ಸ್ ಕೇಳ್ತಾರೆ. ಲಿಸ್ಟ್ ದ ಪ್ರಾಪರ್ಟೀಸ್ ಆಫ್ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಲೈನ್ಸ್ ಆಫ್ ಫೋರ್ಸ್. ಫಸ್ಟ್ ಒನ್ ಏನ್ ಬರುತ್ತೆ, ದ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಲೈನ್ಸ್ ಒರಿಜಿನೇಟ್ ಫ್ರಮ್ ದ ನಾರ್ತ್ ಪೋಲ್ ಆಫ್ ದ ಮ್ಯಾಗ್ನೆಟ್ ಅಂಡ್ ಎಂಡ್ ಅಟ್ ದ ಸೌತ್ ಪೋಲ್. ಸೊ ಎಲ್ಲಿ ಒರಿಜಿನೇಟ್ ಆಗುತ್ತೆ, ನಾರ್ತ್ ಪೋಲ್ ಒರಿಜಿನೇಟ್ ಆಗುತ್ತೆ, ಆಮೇಲೆ ಎಂಡ್ ಆಗೋದಲ್ಲಿ ಸೌತ್ ಪೋಲ್ಗೆ. ತಿಳಿತಾ? ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್? Next, magnetic field lines becomes closer to each other nearer to the pole magnets, but they are widely separated at other places. So at the other places it is widely separated, but nearer to that, the closer to each other, they are very closer to each other. Next, two magnetic field lines do not intersect one another. Two magnetic field lines which are present, though do not interact each other. ನೀವು ಇಲ್ಲಿ ನೋಡಿರಬಹುದು, I'll show you people where they will not interact with each other. Okay, ಇಲ್ಲಿ ನೋಡಬಹುದು, ಇವೆರಡು ಇಂಟರಾಕ್ಟ್ ಆಗ್ತಿದೆನಾ, ಇವೆರಡು ಮ್ಯಾಗ್ನೆಟಿಕ್ ಲೈನ್ಸ್ ಇಂಟರಾಕ್ಟ್ ಆಗ್ತಿದೆನಾ, they both are getting interacted. See, check here, the both are getting interacted. No, they will not get interacted. Clear? Yes. So this 3 points is very important, and this question is also very important. Okay. Must do question. Next comes, why does the two magnetic lines of a force interact each other? This is due to the fact that resultant force of a north pole at any point can be only in one direction. So ಒಂದೇ direction ಅಲ್ಲಿ ಇರಬೇಕು, ಅದು uniform position ಅಲ್ಲಿ ಒಂದೇ direction ಅಲ್ಲಿ ಇರಬೇಕು. But if the two magnetic field lines interact each other, then the resultant force on the north pole placed at a point of the interaction will be longer two direction, which is not possible. So ಅದು possible ಅನೇ ಆಗಲ್ಲ. Okay, this is not possible itself. Okay, they might ask the give reason also on this. Okay, ಇದರ ಮೇಲೆ give reason ಅನ್ನು ಕೇಳಬಹುದು. On this they might ask give reason also. Application based. ಆಯ್ತಾ? Next comes what? The magnetic field in a given region is uniform. Draw a diagram to represent it. So magnetic field is a given, actually is a given region is uniform. Draw the magnetic field. This is the magnetic field. The uniform magnetic field inside the current carrying solenoid. We have discussed already about the solenoid, right? A uniform magnetic field region is represented by drawing the parallel straight lines all pointing in the same direction. It's pointing in the same direction. Clear? Example, the uniform magnetic field which exits inside the current carrying solenoid can be represented by parallel straight lines which is pointing from its S pole to north pole, as shown in the figure. In this way, ಇಲ್ಲಿ ನೋಡಿ, ಇಲ್ಲಿ north pole ಇದೆ, south pole ಇದೆ, north pole ಹೋಗ್ತಿದೆ in this direction. Clear? And the magnetic field lines are in this way. The magnetic field lines are in this way. This much you people remember, it's more than enough. Clear? Next, what is the principle? This is repeated, huh? No. One second, guys. Yes, this is different. Ish questions idave nam kadena. Yes. What is principle of an electric motor? So principle ಏನಪ್ಪ electrical motor do. So a motor works on the principle of magnetic effect. Yes, magnetic effect ಯಾವ ತರ ಆಗುತ್ತಲ್ಲ ಅದರ ಪ್ರಕಾರನ motor use ಆಗೋದು, ಆಯ್ತಾ? So now magnetic effect of a current when the rectangular coil is being placed in the magnetic field. Rectangular coil is being placed inside the magnetic field, is passed through it and force acts on it, the coil which rotates it continuously. Magnetic field electrical field today continue ಆಗ್ತಿದೆ. Means the coil which is we discussed it already discussion. Okay, ಈ ಕಾನ್ಸೆಪ್ಟ್ and discuss ಮಾಡಿದ್ದೇವೆ solenoid ನಲ್ಲಿನೂ. Coil rotate ಆಗಿರುತ್ತೆ rectangular way ನಲ್ಲಿ. Current magnetic effect ಯಾವಾಗ ಪಾಸ್ ಆಗುತ್ತೆ, current will be produced. That's it. Simple. When the coil rotates, the shaft attached to it rotates, and in this way electrical energy has been supplied to the motor and is been converted into mechanical energy of the rotation. So mechanical energy, how it will be converted? In the form of how the magnetics will be converted to the electrical power to the magnetic field. Sorry, magnetic field to the, what is this? Mechanical energy. Clear? Mechanical energy. Next, what is the role of the split ring in the electrical power? So this is also important question. ಏನ್ ಕೆಲಸ ಸ್ಪ್ಲಿಟ್ ರಿಂಗ್ ದು, ಆಯ್ತಾ? A split ring reverses the direction of the current in the armature coil after very half rotation. That is, it acts as a commutator. It acts as a what? Commutator. Clear? And the reversed current reverses the direction of the forces acting on the two arms of the armature after every half rotation. Every half rotation, this is going to come again like that. Okay, so and then this allows the armature coil to rotate continuously in the same direction. It will give that much force, guys, so the rotation will be at a proper uniform way. Clear? Next comes, state the principle of the electrical generator. We have discussed and I have told you people, this is very important. Na ಹೇಳಿದೆಲ್ಲ ಈ ತರ ಕ್ವೆಶ್ಚನ್ ಕೇಳ್ತಾರಂತ. Yes, the electrical generator works on the principle that when a straight conductor is being moved in the magnetic field, then the current is being induced in the conductor. So in an electrical generator, a rectangular coil is made to rotate rapidly in the magnetic field between the poles of horseshoe type magnet. So whenever that coil is being rotating, it cuts the magnetic field lines due to which a current is being produced in the coil. So this electrical generator, how it works is, whenever the principle is, so when a straight conductor is being moved in the magnet, straight conductor means straight conductor carrying current, it will move in the magnetic field, then the current is being induced in the current is being produced in the conductor. Clear? Then if the generator is rectangular in coil, means made a rotate rapidly it will be getting rotated, as we discussed previous question also. Okay, previously adne rotate ಮಾಡಿದ್ರು, same ತರ ಅದೇ ತರ rotate ಮಾಡೋದು, ಇವಾಗ electricity pass ಆಗುತ್ತೆ ಅವಾಗ. Okay, between the poles of the horseshoe magnet there will be used what? Horseshoe magnet will be used, and when the coil rotates, it cuts the magnetic field. When the coil will start rotating faster, this is the coil, okay, rectangular way. So how it will start rotating? No, it will cut it. Okay, it will cut the magnetic field. For that purpose, due to which the current is being produced in the coil. Clear? Next, an electrical oven of a 2 kilovolt power rating is operated in a domestic electrical circuit, that is 220 volt. Okay, that has current rating of 5 ampere. What result do you explain? The electrical oven draws the current given by I is equal to PV. Right? Here what happens? 2 kW divided by P. Kottidare already 2 kilowatt anta power. Okay, power has already given. Power is how much? 2 kilovolt. Right? Next they have given V also. How much it is? Volt. 220 volt. Okay, just we are going to substitute it. This is kilovolt, just we will convert into watt here. Kilovolt ana watt convert ಮಾಡಿದ್ರೆ 2000 watt ಆಗುತ್ತೆ. ಆಮೇಲೆ ಡಿವೈಡ್ ಮಾಡಿಬಿಡೋದು. How much people will get the ampere? That is 9.09 ampere. Current will be what? 9.09 ampere. Thus the electric oven draws the current which much more than the current rating 5 ampere. Okay, then the current rating 5 ampere. This much you people can remember. Next what comes? Next comes what? What precautions should be taken to avoid the overloading of the domestic electrical circuits. So preventions na nimage helde enu stabilizer use ಮಾಡಬಹುದು ಅಂತ ಹೇಳಿದೆ ನಿಮಗೆ example, right? Same ಅದೇ ತರ. So to avoid the overloading of the domestic electrical circuit, the following precautions should be taken. First one is like the mains used. The wires used in the circuit must be coated with the good insulating materials like PVC. So it should be connected. PVC should be very proper. ಯಾವುದೋ normal wire ತಗೊಂಡು connect ಮಾಡ್ತೇವೆ ಅಂದ್ರೆ ಆಗಲ್ಲ. ಸ್ವಲ್ಪ moisture ಆದ್ರೂ it might sparkle. Okay. Next, a circuit must be divided into the different sessions and the safety fuse must be used in the each session. Like example, how I told you stabilizer, safety fusion should be there. Fuse ಅಂದ್ರೆ fuse ಹಾಕಿರ್ತಾರಲ್ಲ ಚೆಕ್ ಮಾಡ್ಬೇಕಂತ ಸರಿಯಾಗಿ ಆಯ್ತಾ. ನೆಕ್ಸ್ಟ್, ಹೈ ಪವರ್ ಅಪ್ಲಯನ್ಸಸ್ ಲೈಕ್ ಏರ್ ಕಂಡೀಷನ್, ರೆಫ್ರಿಜರೇಟರ್, ವಾಟರ್ ಹೀಟರ್ ಎಕ್ಸೆಟ್ರಾ ಶುಡ್ ನಾಟ್ ಬಿ ಯೂಸ್ಡ್ ಸೈಮಲ್ಟೇನಿಯಸ್ಲಿ. ಸೊ ಎಲ್ಲ ಸೈಮಲ್ಟೇನಿಯಸ್ಲಿ ಯೂಸ್ ಮಾಡ್ಕೋಬಾರ್ದು. ಇಲ್ಲಿ ಇಂಡಕ್ಷನು ಆನ್ ಐತಿ, ಇಲ್ಲಿ ಫ್ರಿಜ್ಜು ಆನ್ ಇದೆ, ಟಿವಿನೂ ಆನ್ ಇದೆ, ಎ ಸಿನೂ ಆನ್ ಇದೆ, ಗೀಸರು ಆನ್ ಇದೆ, ಎಲ್ಲ ಕುಂತ ಆನ್ ಮಾಡಿ ಇಡಬಾರ್ದು. ದ ಪಾಸ್ ಆಫ್ ದ ಎಲೆಕ್ಟ್ರಿಸಿಟಿ ಮೀನ್ಸ್ ಎಲ್ಲ ಕಡೆ ಜಗ್ತಿರುತ್ತಪ್ಪ ಎಲೆಕ್ಟ್ರಿಸಿಟಿ, ನಂಗೂ ಬೇಕು ನಿಂಗೂ ಬೇಕು ಅಂತ ಎಲ್ಲ ಜಗ್ತಿರುತ್ತೆ. ದೇ ಮೈಟ್ ಬ್ಲಾಸ್ಟ್. Okay, there might be a sudden reactions. For that purpose we need to be very careful while using the any electrical appliances, anything. Okay, ನೀವು ಕೇಸಸ್ ನೋಡಿರ್ಬೇಕು. ಫೋನ್ ಚಾರ್ಜ್ ಇಟ್ಕೊಂಡು ಮಾತಾಡ್ತಿರ್ತೇವಲ್ಲ, electricity sometimes it will pass more, it might blast. So many people have faced this problem. ಗೊತ್ತಾ ನಿಮಗೆ? ಎಷ್ಟು ಮಂದಿ ಮೊಬೈಲ್ ಗೇಮ್ ಆಡೋದಕ್ಕೂ ಮುಂದೆ ಬ್ಲಾಸ್ಟ್ ಆಗಿದೆ. ಸೊ ಇವೆಲ್ಲ ಆಗಿದೆ. ದಿಸ್ ಇಸ್ ವಾಟ್ ಯು ಪೀಪಲ್ ನೀಡ್ ಟು ಬಿ ವೆರಿ ಕೇರ್ಫುಲ್ whenever you people are using any electrical appliances. ಆಯ್ತಾ? ಸ್ಪೆಷಲಿ ಇನ್ ಕೇಸ್ ಎಲ್ಲಾದ್ರೂ ನಿಮಗೆ ಅನಿಸ್ತದೆ ಲೀಕೇಜ್ ಇದೆ, ವಾಟರ್ದು ಏನೋ ಇದೆ ಅಂತ, ಸೊ ಆ ಕೇಸಸ್ನಲ್ಲಿ ಅಂತೂ ನೀವು ಭಾಳ ಯೂಸ್ ಮಾಡೋದು ಚೆನ್ನಾಗಿ ಸೋಕಾಸಾಗಿ ಯೂಸ್ ಮಾಡಬೇಕು. ಸೊ ಸ್ವಲ್ಪ ಮಂದಿ ಏನು ಮಾಡ್ತಾರೆ ಅಂದರೆ ಗೀಸರ್ ಆನ್ ಮಾಡಿಬಿಡ್ತಾರೆ, ಗೀಸರ್ ಆನ್ ಇಟ್ಟನೆ ಜಳಕ ಮಾಡಿಬಿಡ್ತಾರೆ. ಸೊ ಆ ಟೈಮ್ದಲ್ಲಿ ಭಾಳ ಕೇರ್ಫುಲ್ ಆಗಿರ್ಬೇಕು ನಾವು. ಗೀಸರ್ ಆನ್ ಇಟ್ಟು ಜಳಕ ಮಾಡಬಾರ್ದು. ಸೊ ಆಫ್ ಮಾಡಬೇಕು, ಆಮೇಲೆ ಯೂಸ್ ಮಾಡಬೇಕು. ಬಿಕಾಸ್ ವಾಟರ್ ಮೈಟ್ ಪಾಸ್ ದ ಕಂಡಕ್ಟರ್, ಸೊ ಎಲೆಕ್ಟ್ರಿಸಿಟಿ ಮೈಟ್ ಬಿ ಪಾಸ್ ಫ್ರಮ್ ದ ಕರೆಂಟ್. ಸೊ ಇನ್ ಕೇಸ್ ನೀರಿನಲ್ಲಿ ಎಲೆಕ್ಟ್ರಿಸಿಟಿ ಪಾಸ್ ಆದರೆ ಯು ವಿಲ್ ಬಿ ಗಾನ್. So you should be very careful whenever you people are using such appliances like electrical appliances use ಮಾಡೋದು ಮುಂದೆ ಭಾಳ ಕೇರ್ಫುಲ್ ಆಗಿ ಇರಬೇಕು. ತಿಳಿತಾ? ಸೊ ದಿಸ್ ಇಸ್ ಆಲ್ ಅಬೌಟ್ ದ ಚಾಪ್ಟರ್ ಮ್ಯಾಗ್ನೆಟಿಕ್ ಫೀಲ್ಡ್ ಆಫ್ ಎಲೆಕ್ಟ್ರಿಕಲ್ ಕರೆಂಟ್. ಸೊ ಇದು ಫಿಸಿಕ್ಸ್ ಚಾಪ್ಟರು, ಇಲ್ಲಿ ಮೇಲೊಂದು 8 to 9 ಮಾರ್ಕ್ಸ್ ಕ್ವಶನ್ ಬೀಳುತ್ತೆ. ಸೊ ಐ ಹ್ಯಾವ್ ನಾಟ್ we didn't study about the numerical problems here, but as I told you people, we are going to learn the most important questions which has been come from this chapter, that we will do a separate video. ಆ ವಿಡಿಯೋನಲ್ಲಿ ನಿಮಗೆ ಎಲ್ಲ ಹೇಳ್ಕೊಡ್ತೇನೆ ಆಲ್ರೆಡಿ, ಯಾವ ಥರ ಕ್ವಶನ್ಸ್ ಬಿದ್ದಿದೆ ಮತ್ತು ಯಾವ ನಂಬರ್ಗೆ ಬೀಳುತ್ತೆ, ಯಾವ ಥರ ಕ್ವಶನ್ಸ್ ಬೀಳಬಹುದು ಅನ್ನೋದು ನಿಮಗೆಲ್ಲ ಆ ಕ್ವಶನ್ಸ್ ಅಲ್ಲಿ ಚಾಪ್ಟರ್ ವೈಸ್ನಲ್ಲಿ ಗೊತ್ತಾಗುತ್ತೆ. ತಿಳಿತಾ? ಸೊ ಈಗ ಜಸ್ಟ್ ನೀವು ಥಿಯರಿ ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್ ಮಾಡ್ಕೊಳ್ಳಿ. ಯಾಕಂದರೆ ನವೆಂಬರ್ ತನಕ ನೀವು ಫುಲ್ ಥಿಯರಿಯನ್ನು ಕಂಪ್ಲೀಟ್ಲಿ ಸ್ಟಡಿ ಮಾಡಿಬಿಟ್ರೆ ಡಿಸೆಂಬರಿಂದ ಫುಲ್ ಕ್ವಶನ್ ಪೇಪರ್, ಸ್ಯಾಂಪಲ್ ಕ್ವಶನ್ ಪೇಪರ್ ಸಾಲ್ವ್ ಮಾಡ್ಬೋದು. ಅವನ್ನೆಲ್ಲ ಮಾಡಿದ್ರೆ ನಿಮಗೆ ಜನವರಿನಲ್ಲಿ ಪ್ರಿಪ್ರೇಟರಿ ಎಕ್ಸಾಮ್ಸ್ನಲ್ಲಿ ಆರಾಮಾಗಿ ಸ್ಕೋರ್ ಮಾಡ್ಕೋಬೋದು. ಆಯಿತಾ? ಸೊ ದ್ಯಾಟ್ ಇಸ್ ವಾಟ್ ಐ ಆಮ್ ಮೋಟಿವೇಟಿಂಗ್ ಯು ಪೀಪಲ್ ಟು ಡೂ ದೋಸ್ ಥಿಂಗ್ಸ್. Make sure you people will follow those things also. Clear? So till then, see you everyone, and make sure to subscribe to the channel if you're very new to the channel. Till then, see you everyone.